Hello class, today we are going to look at how to use trig ratios to find angles of a right triangle. In the previous video we saw how to use the trig ratios to find the sides of a right triangle. In this one we are going to find the angles of a right triangle. Alright, so let's just take a look at an example here. So I already have the SOHCAHTOA written up there, so that'll remind us. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Now, got my right triangle, triangle ABC here. I have two of the sides, and what I want to do is I want to find the values of the angles. The measures here, how many degrees is angle A, how many degrees is angle B. Alright, so we'll just start with angle A. And so from angle A, I want to find one of my trig ratios that I can use for angle A. So looking at angle A, which two sides do I know? Well, let's see here. I know the 56, which is the hypotenuse. So hypotenuse, that means we're either going to be using cosine or sine, because those are the ones that have the hypotenuse in them. And I also have the 36, which from angle A is opposite the angle, right? Opposite, so that's not going to be cosine because that has adjacent. It's going to be opposite, so I'm going to be using sine. All right, so I'm going to set up my ratio, sine of angle A, and then it's opposite over hypotenuse, so 36 over 56. So there it is. Sine of angle A equals 36 over 56. Now, this is the sine of angle A, but I just want angle A, which means I have to get rid of the sine. Something I see a lot of people do is they want to divide by sine. Sine is not a number. You can't divide by sine. It's an operation, just like addition and multiplication, things like that. So dividing by sine would be like saying I'm going to divide by subtraction, which makes no sense at all. What we need to do is we need to do the opposite of finding the sine. Just like if you have squaring something, you have to do the opposite of squaring, and you have to square root it. We're going to do the opposite of sine, which is called the inverse sine, and that is written like this. It's the sine to the negative 1. So on your calculators, it'll be that sine with a negative 1. All right. So when you do that, well, it's the inverse, so it cancels out the sine over there. So over here you have sine of this sine negative 1, this inverse sine of 36 over 56. So A is the inverse sine of 36 over 56. And we're going to put this into the calculator here. So let me turn the... I want to see what my problem is. There. All right. So inverse sine. So on a TI calculator, notice it's in blue right there. So second inverse sine of 36 over 56. Close my parentheses. And I get 40.005. Oh, very quickly, do make sure that you are in degrees, which I am, right there, in degrees. So click my mode, not in radians, because a lot of times the TIs default into radians. So make sure that you change it from radians to degrees by clicking the mode right there. All right, but I am in degrees. So inverse sine of 36 over 56 is 40.005. All right. So, round it off, the measure of angle A is 40.01. So, there's that. That's angle A. Now let's find angle B. Angle B, so we're looking at this one up here now. So from angle B, I still have the same numbers. Still have the 56 and the 36, still on the sides I have. 56 is still the hypotenuse. That doesn't change. But the 36 is no longer opposite, right? Because I'm looking at a different angle. So instead of being opposite to angle B, it is adjacent to angle B. So inside right there next to it, the leg. So instead of using sine, I'm going to be using adjacent and hypotenuse. So that would be cosine. So the cosine of angle B equals 36 over 56. So we're using cosine, not sine. Again, we want to get rid of the cosine. So to do that, just like over here, to get rid of sine, we use the inverse sine. To get rid of cosine, we're going to use the inverse cosine. So the cosine cancels out, and I'm just left with B is equal to the inverse cosine of 36 over 56. Because remember, you do it to one side, you got to do it to the other side. Equations have to stay balanced. All right. So we'll take this and we'll stick that in my calculator. All right. So inverse cosine right there in blue. So second cosine, and it is 36 over 56. Close my parentheses and 49.994. All right. So we're going to round that off. Again, remember, these are almost always going to be irrational decimals. They go on forever. So you're going to have to round. So whatever your problem tells you to round to, I always round to 2 decimal places unless the problem says otherwise. So 49.99. There you go. So the measure of angle B is 49.99. One thing I do want to point out, if you'll notice, these two angles here add up to 90. Because these are the acute angles of a right triangle, so to get B, I could have just taken the 40 and subtracted it from 90. Because all three angles have to add up to 180, and I already got 90 right there for the right angle. Alright, so let's do one other one. Let's come over here. I don't want that anymore. Alright, so here's one in the delta math. Let's see here. In triangle IJK, the measure of angle K is 90 degrees, so there's my 90. Length of JK is 6.4 feet. Length of KI is 7.3 feet. And we want the measure of angle J to the nearest degree. So this one we're going to round to the nearest whole degree. Okay. So again, I got my SOHCAHTOA here. Let's see. So I'm looking at this side. I'm looking at this angle. So I have the 6.4. Well, that would be adjacent. So that is going to be either cosine or tangent, and I have the 7.3, which is opposite. So that means I'm going to be using tangent. Alright, so let's see here. We've got tangent of which angle? Tangent of J, I don't know what that is, going to figure that out, is equal to opposite, so 7.3 over the adjacent, which is 6.4. All right. Now that's tangent, so I want to get rid of the tangent. I don't want tangent. I just want J, right? So just like we did with sine and cosine, we got my calculator here, and we are going to do the inverse tangent. So functions here, inverse tangent right there. Inverse tangent of 7.3 over 6.4 is 48.758, and we want to round to the nearest degree, so 48 point, and that's going to round up, so 49. All right. Always pay attention to what it wants you to round to. You sure I want to do this? Yes, I am. And we get a nice big green check mark there. So we're good. All right. So, just to review, when you're doing this, whichever angle you're looking for, find out which two sides you have so that you can set up your ratio. Right? If it's opposite, hypotenuse, adjacent, hypotenuse, whatever it is, so you know sine, cosine, and tangent. Set up your ratio, and then you're going to do the inverse of that ratio. So inverse cosine, inverse sine, inverse tangent, which are right here on the TI 84s, right? Second functions, that's what that is. All right. Also, again, very important, make sure that you are in degrees, not in radians. All right. Hope you found that useful. Now we'll see you in the next video.